Firewall technology emerged in the late 1980s when the internet was brand new and global connectivity was still very limited. Over the next 2 decades, firewall technology evolved dramatically. Today, next-generation firewalls have created a revolution in data protection. Through application layer filtering, next-gen firewalls have the greatest level of control and security on the market. As the overall landscape of computer technology is constantly shifting by nature, security specialists take a dynamic approach to their products. First, the product management team identifies an opportunity in the current network security market that they will address. Once they've determined the requirements and designed the architecture, a prototype is built and tested. Then it goes into mass production. This starts at the kitting station, where the components are all gathered up. Next stop is the solder paste printing machine. Here, solder is deposited to the board via metal stencil. A squeegee wipes paste over the stencil. Once heated, this will bind the components to the board. Now it's time for the chip shooter. Here, a turret picks up the smaller components to place on the board according to the layout programmed into the software. After the chip shooter is finished, the boards are inserted into the IC placer. This is similar to the chip shooter, but handles placing the larger components on the board. Next, the board is put into the reflow oven, where 220-degree heat causes the solder to melt and bind together. At this point, the bottom of the board has been built. Once this is complete, the board will be flipped and the top will be built in the same process. Each time the board comes out of the reflow oven, it is visually inspected for quality control. The board is also subjected to an automatic optical inspection, or AOI. Here, a computer checks for orientation of components, missing components, alignment, and part marking. Now the board is brought to the stuffing station. Not turkey stuffing, part stuffing. All the parts that must be installed by hand are done at this station. Next, the boards are placed on a conveyor belt and run through the wave soldering machine. Inside the machine, all the pins on the bottom of the board are soldered together. Now the board goes through another quality control inspection, making sure everything has been assembled perfectly. The 5D X machine inspects the boards further, using X-rays to verify that each solder joint is to spec. Final components that need to be press-fit are attached at the next station. And then the in-circuit test machine, the ICT machine, tests the circuits on the board by powering them on. The heatsink and battery are installed by hand as well. The circuit board is now complete. Final quality assurance tests are performed. Visual inspection and PCBA functional testing will ensure that the circuits are operating to spec and all the ports are communicating. Now the boards are moved to another building where the enclosures are being built. Employees call this area the supermarket. Here they go shopping, not for vegetables, but for more high-quality components. The components are gathered, and then a robot, called the water spider, delivers the parts to the workers who will build the box. The enclosure box is built by hand at the first workstation. Once completed, the box is tested similarly to the circuit board. Diagnostics and port traffic are confirmed. Next, the box is powered on and run for 6 hours. This is called a run-in. This allows the components to heat up to operating temperature and ensure that there are no issues. After the run-in, the diagnostic software is replaced with the final operating system. Now, a final high-voltage grounding test ensures that there are no shorts and the box is within all technical compliances. The final product, now tested and ready for action, is carefully boxed and sent out to the warehouse for shipping. As the orders are received, a forklift pulls the boxes and the warehouse staff ship them out.